Hi, this video is designed to remind you or give you a sense that if we are interested in solving higher order polynomials, and by higher order I really mean any degree higher than 2, so 3 and above, then instead of coming up with new strategies for solving those polynomials, all we're trying to do is depress them or break them down into smaller degree polynomials. So I've got a great example here to share with you that I did in class as well. The polynomial is a cubic polynomial. You can see that it has a degree of 3. So this cubic or third degree polynomial is the one that we're interested in solving, but it's really intimidating. We're not sure what values of x are going to make this equation equal to 0. So let's assume that we were able to somehow, some way factor this third degree polynomial. So you can believe me when I say the product of these three factors will return this cubic polynomial. Now I get to say that each of these factors is a linear or first degree polynomial. So all I'm trying to say is that we have the expanded version of a cubic polynomial here. We have its factored form, and I am arguing that being able to write a polynomial in its factored form so that each of these factors is a lesser degree than what you started out with is incredibly valuable. Why? Here's why. Each of these linear factors, it's really easy to find its solution. So for instance, x plus 3 is equal to 0. X has to be negative 3 in order for this whole equation to be 0. And so on for these other linear factors. We get solutions of 5/2 and 7. The connection here that I want you to make, this kind of content connection that I want you to make is, each of these solutions, this negative 3, 5/2, and 7, not only does it satisfy each of these linear factors, but each of these solutions also satisfies the original cubic function. Here's some proof of that. Here I am trying to find out what f of negative 3 is for the original cubic function. And you'll notice that as I input negative 3, slowly but surely, the sum and difference of all these values ends up being 0. So what have I learned? That at the same time that negative 3 is a solution to this linear factor, negative 3 is also a solution to that third degree cubic polynomial. That's why we want to have the ability to depress polynomials. On a kind of side note, but certainly related note, here's another example that we covered in class. This time, again, we have a third degree polynomial, x cubed plus 64 equals 0. It so happens that this is a sum of cubes. Students in class started recognizing the structure where if this is the general factored form of a sum of cubes, we can apply that to our problem as well. The point I want to make here, what I want you to draw your attention to is, we've just taken a third degree polynomial and we've written it as the product of a linear and a quadratic polynomial, a first degree and a second degree. So given the math work we've done this year, you should have the skill sets to solve for that linear equation. You get an answer of negative 4, and to solve the quadratic, where you get these two imaginary solutions. What's the connection I want you to make again? That these three solutions are also solutions to the cubic. One of them is real, two of them are imaginary. If you were to graph this function, you would see that real solution at negative 4. You wouldn't see these other solutions, these two imaginaries, but you would know that they satisfy this original function. Thanks for listening.